The first reason to study the history of science is to cultivate a deeper interest and motivation to learn science. I would claim that compared to the typical textbook questions, the kinds of questions that the history of science deals with, which we saw in the previous video, are more fundamental, more interesting, and ultimately more helpful to pursue if we really want to acquire a deeper interest in science. Now, why do I say this? Firstly, those questions require an examination of the lives of real people like you and me, whom we call as scientists. They require an examination of the lives of the scientists, not just some abstract theories and formulas. There is mystery and adventure to be found in their life stories. So, who wouldn't enjoy such stories? Secondly, the questions those real people were pursuing and the ideas they came up with in trying to answer those questions were much bigger and deeper than the narrow, superficial applications to which those ideas might be put today, particularly in textbook problems. Here's a quote from the famous astronomer Johann Kepler. I also ask you, my friends, not to condemn me entirely to the mill of mathematical calculations, and to allow me time for philosophical speculations, my only pleasures. You can see from this quote, which is actually from a letter that Kepler wrote, that when he was doing astronomy, he was doing something more than just mathematical calculations to compute some answer. In fact, he sees his work in astronomy as a part of philosophy. Incidentally, what we today call as science was in those days called as natural philosophy or the philosophy of nature. So, science was really a part of philosophy in those days. Here is another quote from Kepler. I wanted to be a theologian. For a long time I was unhappy. Now behold, God is praised by my work even in astronomy. So his work in astronomy for him was really a part of philosophy, and as a theist, Kepler saw himself as worshipping God through his work in astronomy. Now, other scientists have had other deep reasons for doing science. Here is a quote from the evolutionary biologist and prominent atheist Richard Dawkins. After sleeping through 100 million centuries, he's referring to the time span of evolution, we have finally opened our eyes on a sumptuous planet, sparkling with color, bountiful with life. Within decades, we must close our eyes again. Isn't it a noble and enlightened way of spending our brief time in the sun to work at understanding the universe and how we have come to wake up in it? This is how I answer when I am asked why I bother to get up in the mornings. So, when we study the origins and development of science through the lives of the humans engaged in it, that is, through the lives of the scientists, and when we look at the political or religious or spiritual and social and economic factors profoundly influencing and shaping their ideas, we realize that science is ultimately a human activity. Scientific theories don't suddenly pop out from the heavens. They also don't pop out from the minds of lone geniuses. To do good science, we don't have to be infallible geniuses. Science has been developed by fallible humans just like us who were thinking systematically about fundamental questions that excited them as human beings, carefully observing the world around them. Their thought processes were influenced by the time and place that they were living in, by the religious beliefs that they had, by the works of other scientists who lived before them or during their time, and by their own experiences. Sir Isaac Newton famously wrote in a letter, "If I have been able to see further, it was only because I stood on the shoulders of giants." So here Newton is referring to the fact that for doing his work, he depended on the work that had been done by previous scientists. So Kepler, Newton, and others were not engaged in some abstract and impersonal study of a dry subject meant to bore or torture students in the classroom. They were passionately pursuing questions that excited them as curious human beings living in this world. And that same curiosity is present inside us too. We just have to find a way to kindle it. The astronomer Carl Sagan once wrote, "I find many adults are put off when young children pose scientific questions. Why is the moon round? The children ask. Why is grass green? What is a dream? How deep can you dig a hole? When is the world's birthday? Why do we have toes?" Too many teachers and parents answer with irritation or ridicule or quickly move on to something else. What did you expect the moon to be? A square? Children soon recognize that somehow this kind of question annoys the grown ups. A few more experiences like it, and another child has been lost to science. So, this means that we too have the potential of becoming scientists, or at least well informed about science, if we nurture our curiosity by systematically pursuing the kinds of questions that earlier scientists were stimulated by. They made lots of mistakes, just like we make mistakes. It is in fact very instructive to look at the numerous mistakes and blind alleys that earlier scientists were led into before they could finally come up with their theories that we learn in their present form. Many of their stories have all the excitement, all the suspense, and all the thrill of, say, a treasure hunt or of a gripping mystery novel. We just have to find the right way to immerse ourselves into the world that they lived in and become a part of it. Learning any subject through stories is easier because we enjoy listening to good stories. They capture our interest and attention. So I think that a lifelong interest in science will be much easier to cultivate if we study the history of science.